perimeter and area ratios. Let's start by just figuring out what the connection is between these. So, Nasia, come write the perimeter. Alea, come write the area. Kaylee, write the perimeter. Austin, come write the area. And you can write these on your notes pages too. Find the perimeter and the area. Oh, none of them. Not on your notes. Never mind.
Thanks, B.
Go write the perimeter of the green one.
Love you, Alea, but wow.
Awesome. Area. Face on side. Come on. We're be waiting on you.
80.
Don't just go
Just grab anyone today, Kendall, because we're so empty.
Sounds like a cartoon.
This is not on your notes page. This is a discovery. We're discovering what the lesson is, okay? So, thank you very much for filling those in. Is it 80? Can you fix that, please, Austin? No.
Oh,
Nice.
tell them that. I put 16th
Well, it was his bad for relying on you. He should have done it himself.
Why trying to find that paper?
All right.
My bad. What is that?
Kendall, what's the scale factor from the pink to the green?
What?
What is the scale factor? What?
3.
Perfect. 3. Okay. So that green rectangle is 3 times bigger than the pink one, right? What's 2 times 3? 6. What's 5 times 3? 15. Okay, so it's 3 times bigger. That's the scale factor. Now,
What did you say?
it's from Friday.
Yeah.
It's from Friday. Now, here. When I say the word ratio, you should immediately think division. A ratio just means to divide. So, if I want to know the ratio of the perimeters, I want everyone to divide these right now. 42 divided by 14. Go. (42 divided by 14). What are you getting?
3.
3. So what do you notice about the ratio of the perimeters and the scale factor? They are the same. Okay. What about the area? Let's divide that one. 90 divided by 10. It's 9. It's not 3. So the scale factor, the perimeters, those are the same. What happened when we went to area? Multiply? Maybe. What if I said this? This is 3 to the 1, and this is 3 to the 1. Then what would you say?
9.
You would say 9?
No.
Alea? Say it louder. 3
What did you say?
to the 2. This is 3 to the 1, 3 to the 1, and this is 3 squared. Now, a perimeter. How many D is a perimeter? 1D, 2D, 3D. A perimeter. 1-dimensional, 2-dimensional, or 3-dimensional? A perimeter. Okay, no one's answering. Let's start with this. How many D is a side? This side right here, is that 1D, 2D, or 3D? 1D. Thank you, Nasia. Julius and Kendall, you're killing me. A side is 1D. When you just add up sides, are you now 2D? The sides of this rectangle, is that 1D or 2D? We need to know this is important.
What?
A perimeter.
Okay.
Is it 1D, 2D, or 3D? It's still 1D. A perimeter, a scale factor is 1D. A perimeter is 1D. What about an area? 2D. 2D. So do you notice how when it's 1D, it's the scale factor to the 1, and when it's 2D, it's the scale factor to the 2. What would be 3D?
3 to 3.
Right. 27 would be 3D, but what would represent 3D? It's not area, it's not perimeter. Did you say it? Starts with a V. Volume. Okay, so that'll be next unit, so we don't have to worry about that today. Write this on your notes. Write this on your notes. The ratio of the sides is A to B. The ratio of the perimeters is A to B. The ratio of the areas is A squared to B squared. All right. Oh, you're putting it back? Don't worry. Just set it down. I can file it away. No,
I'm so glad.
And yeah, on your paper it says ratio of the dimensions. Dimension is same as sides. Dimension and side are the same thing. A dimension is like a length, a width, a height, a perimeter. Well, not really a perimeter. A diagonal. So the moral of the story is that if it's 1D, you raise it to the 1. And if it's 2D, you raise it to the 2. That's the moral of the story. How easy is today's lesson? By the way, people might call this the similarity ratio or the scale factor. So don't freak out if you see the word similarity ratio. It's just A to B, just the scale factor. Oh my goodness, the sound effects. I would think that Dimitri's in our room today, but he's not. All right.
Yeah, his noises are just crucial.
Anyway, did you mean to say crucial?
I said crucial.
Yes.
Is that the right word you wanted to choose?
I have no idea.
Given the following squares, find the ratio. Okay, go. Write down the ratio of the sides. Write down the ratio of the perimeters. And write down the ratio of the areas. Go. Ratio means like 1 to 2, 3 to 7, 4 to 9. Those are ratios. Put a colon or a division sign. You're right here. So I'll start you off. The ratio of the sides, I'm just going to write the sides. 4, 2, 7. So John, what would be the ratio of the perimeters?
4 to 7.
Yeah! So that's what this lesson is all about. It's kind of about a shortcut. Could I find the perimeter of that one and find the perimeter of that one and then write the ratio? Sure it could. But that would be too much work. But let me prove it to you that it works. The perimeter of this one would be, if it was 4 on every side, be 16. And this was 7 on every side, it would be 28. So go to your calculator and do 16 divided by 28, math, enter, enter. What do you get?
4 over 7.
4 to 7. So what this lesson is telling you is you don't have to find the perimeter. You don't have to find the perimeter because the sides are 1D and the perimeters are 1D, so they have the same ratio. It's cool. It saves you work. It's a shortcut. All right, moving around the room. Julius, what's the ratio of the areas? 2D. Raise it to the 2. 4 squared. 4 squared. 16. 7 squared. 7 squared.
49.
7 times 7.
49.
Football team in California. Oh, man.
49ers. Wow.
Yeah.
Even I got that.
Okay. Are we okay with this? 4 to 7, 4 to 7, 16 to 49. This is not rocket science. Rocket science. Did I say that weird? Okay.
Yes. Like you said, right?
Rocket science. Next one. Now we're talking about hexagons, but guess what, guys? We could care less if they're hexagons. We don't care. All we care about is it 1D or 2D?
1D.
What did I give you? It is 2D. Did you see my little hint? Inches squared, This is a 2D figure and a 2D figure. So is that the ratio of the sides or is that the areas?
Areas.
So we already know this one. Ratio of areas, we don't have to do any work there. It's 100 to 169. Now you can't reduce that, but if you could reduce it, you would need to. How do you reduce something? No, reduce it like this. 2 to 6. How do you reduce that? Or divide it and do math enter enter, right? Math enter enter will handle it for you. Anyways. All right, Kenneth, what would be the ratio of the sides? Okay, so this is a squared to b squared. How do you undo squaring something? What's the opposite of squaring? There you go. Square root of 100. 10. And then ask your calculator, unless you already know, square root of 169. Aw, cousin Kenneth. 13. Ashley, what is the ratio of their perimeters? Yes! Very good. Sides are 1D, perimeters are 1D, so you don't have to do any work. They're both one-dimensional. Very nice. Wait, did you say wait?
Yeah.
No way.
Yes, wait.
Okay. This is old news. On this one, you're going to set up a proportion. So please set up a proportion and cross multiply. Complaining about it makes it so much better. Set up a proportion and cross multiply. 15 is to 12 as 115 is to x. 15 is to 12 as 115 is to x. Second over first equals second over first.
We get 13.
He meant 12.
Oh, you know. That's from last problem. Why are they not helping the kids get better with the test?
We need a break.
One person is not even nobody. If there's one student, there should be learning. Alright, cross multiply, Melanie, what'd you get? Why save one life? Why?
To go out in the hallway and learn, and then we watch a movie.
Yeah, but they could do that. Anyways, what'd you get, Melanie? For cross multiplying, 115 times 12 divided by 15. What? 92? Okay. Since this was one-dimensional and this was one-dimensional, we were allowed to cross multiply. So this was a basic problem. What's our units, 92? Inches. It's not inches squared because perimeter is 1D. That was basic. Let me show you what happens when you mix 1D with 2D. Let's look at the next one. These are similar. What? What are they? What are those? Octagons. Yeah, they're polygons, but more specifically, they're octagons. But remember, we don't care that you're an octagon. We don't care that you're an octagon. All we care are the dimensions, 1D or 2D. Let's start out how we did last problem. 9 is to 15 as 45 is to x. Now, don't cross multiply. Do not yet. 9 and 15, are those 1D or 2D values? I sound really weird when I say 2D. Anyways.
1D.
1D. Very nice. Those are sides. Sides are 1D. What about 45 and x? Are those 1D or 2D? Area. 2D. Now take a look at that. Those ratios are in a fight. This one's saying 1D, 1D, and this one's like, no, 2D, 2D. You cannot cross multiply them when they're fighting. Who's going to win? What does our answer need to be in? What dimension?
Inches squared.
2D. Our answer needs to be 2D, so 2D wins the fight. You need to convert everybody to 2D. How do you convert? Very good. Who said that? Kenneth. Square it, square it. Oh, now everybody's 2D and they're happy, and now you can cross multiply. So 15 squared times 45 divided by 9 squared. You cross multiply, but they have to be squared. This is the most important slide of the whole lesson. Back to the beginning.
I got it.
Oh, okay, Kendall. 125?
Yes.
What?
Inches.
Inches squared, because it's a 2D answer. All right. Ooh, the next problem has lots of words. I'll let you read it. Pizza! Do you want to eat pizza this weekend? I did. Last night? Read the problem about Lauren.
It was so really cool. Like, I want it.
Hey, are y'all reading this problem?
I want it. Just be afraid.
Exactly. Oh, there was some quick.
What? Just be afraid.
Hey, do y'all ever get to those district problems on the test that have all those words and you're like, why didn't we go over this in class? We are. We're going over it in class. Sometimes y'all just don't pay attention to these because they have so many words that you just tune out. We need to practice it so you can be better at it on the
Why
test.
would you order one large and one medium?
Because you're feeding the little
Why not get
kids
two
and the
large
adults.
pizzas?
Shorter 2 pizzas. You know when you order a pizza, the size is based on diameter, right? Like if you order a 12-inch pizza, that's the diameter. It's not the circumference, it's the diameter.
No, the circumference is diameter times.
Pi times diameter,
There
yes.
you go.
So, this one is 4 times smaller than this one. 4 times smaller, the diameter is. Hey, wait. Is diameter 1D or 2D? A diameter.
3D.
A diameter, is it a 1D or a 2D figure? Just a length. So yeah, it's 1D. So in 1 dimensions, it's 4 times smaller. That's just 1D. What is this asking about? Let's see. What can you conclude about the
Surface area.
surface areas? How many dimensions is an area?
2D.
2. So we need to take that 1/4, which is a 1D value, and how do we convert to 2D?
Squared.
Thank you, Kenneth. Again, he's on top of it. What's 1 squared? 1. What's 4 squared?
700.
Which answer do you want to choose?
C.
And on the test, people are going to choose this one, or they're going to choose this one. They're just going to double 4 instead of squaring it. Do we know the difference of doubling and squaring? It's hard to believe that this one, the area of this one is 16 smaller than this one, but it really is. If you take the diameter and you shrink it by 4, you're shrinking the area by 16. Okay. We're going to stop right there.